So this year's been a great year for engineering. NASA was able to land a rover right on Mars using this thing called a Sky Crane. If you haven't seen the video, it's really cool. I've attached it to the end of this video as well. But in the classroom, you can just tell everyone, just search YouTube for NASA Sky Crane. Anyway, the point is that they take the rover and they drop it down onto, they blast it off, drop it down to the surface. It's very cool, kids will love it. But we're going to take that and we're going to expand that to an egg drop. So an egg drop is basically, they have to build some kind of package to be able to drop an egg from a distance, let's say, 5 feet, and it has to land without any problems. So let's just get to the materials and we'll go from there. So the materials we're going to use today are 2 pieces of paper, 2 rubber bands, 6 marshmallows, and our engineer. What we want to do for the younger kids, for example the 2nd and 3rd graders, we're just going to go through this and just give them these exact materials, have them design it as we say, step by step, and then we'll all test it together. For the older kids, so 4th, 5th, and 6th, for those guys we're going to basically allow them to use whatever materials they want. For the 4th graders, you might want to help, kind of show what you can do with the marshmallows to cover the egg, and then they have to design something. And then for the very older kids, the 7th, 8th, and above, we're going to throw in we're going to throw in some straws as well, that they have options. And with them, we're going to basically monetize it so that the various objects they cost money. So the object there would be to build the least expensive egg drop that can also survive that 6-foot fall. Now this design that we're going to build is actually only going to be probably good for about a 3-foot fall. So for little kids, don't try to drop it from top of your head until you know that it works from really close, or you're doing it onto a carpet or something. So anyway, let's get started. So move our little engineer, and the first thing we do is we take our engineer and we start splitting marshmallows. So we give him some ears, give him a hat and the bottom. Basically, we're just trying to pad him with as many marshmallows as we can. And now we're gonna put marshmallows there, and we're gonna flip them over and put some marshmallows here and here, and maybe split these up even further. Basically just, we're just trying to put as much protection on this guy as we can. So what do we got here? We got this and this, and then one more. We can put a little bit there, split this guy, and put him there. So now we got a nice little package, except for over here, but we can move them around a little bit. So anyway, the next step is wrap them up. So you take the long edges, you go over, take the short edges, fold, and fold, okay, and there, and now we flip it over, and we do the same thing. Take the long edges, fold, short edges, simple, crinkle, and probably the crinklier this is, probably the better. Now we have that. And of course they're going to be doing this in their groups, so you can have different people be doing different tasks. And there we go. Got a nice little egg package. So now, let's test it out. Okay, just got to wait for the landing area to be clear. Should be good enough. And we drop it. Alright, let's find out if it worked. So far so good. Yeah. Let's see how he's doing. How she's doing. Yeah, our engineer's doing great. So that's basically it. If you want to stick around, at the end of here we have a video from NASA. Again, you can just search for it by going to NASA Sky Crane. Just search that on YouTube. Or we have the video on the website and you can put it on a thumb drive and bring it in. So enjoy.
Hi, my name is Steve Lee. I'm here to tell you about our entry, descent, and landing sequence, which is the way we're going to land our rover named Curiosity on the surface of Mars in 2012. During entry, the Mars Science Laboratory uses a series of thrusters to maneuver through the atmosphere towards the landing site. Once it slows down to Mach 2, a parachute is deployed and the vehicle slows down further. The heat shield is released and the radar is then exposed, which begins taking measurements of the height above the ground and the vehicle's speed. The wheels are released in preparation for a final touchdown. The Mars landing engines warm up and the vehicle separates from the back shell, maneuvering away from the parachute to get to a clear, safe spot for landing. Final vertical descent precedes a sky crane maneuver, during which the rover is separated from the descent stage and lowered on a bridle 7.5 meters long. The descent stage slowly lowers the rover towards the ground at a speed of about 0.75 meters per second. After touching down on its wheels, the rover is stable. The descent stage senses the offload, cuts the bridle, and flies away to land a safe distance away from the rover. Once on the surface, the Curiosity rover deploys the remote sensing mast. This mast contains a series of cameras used throughout the mission. After ground controllers assess the terrain in the immediate vicinity of the rover, it can be commanded to start roving. The rover is able to take images, process those images, and determine the safest path to drive to get towards the goals set by the ground controllers. Curiosity is able to turn in place and rove over rough terrains and rocks. Curiosity's science mission is designed to last at least one Mars year, which is 2 years on Earth. The rover is also designed to rove at least 20 kilometers on the surface of Mars.